You're watching Statistics Made Simple and I am Savita Valsang. In this video, I'll find solutions to section E of the model question paper. Section E, 8th main, answer any two of the following questions. 5 into 2 is equal to 10. So in section E, there will be 4 questions and you have to answer any two of them. 41st one, the mean and standard deviation of a normal distribution are 170 and 6 respectively. Find the probability that the value of the variable selected at random will be subdivision A below 155, subdivision B below 170 and 182. So let me start with the solution. Under solution, let us first write the parameters which are given for the normal distribution. So I will write given mean. So mean is nothing but mu, which is equal to 170. And standard deviation means it is sigma, which is equal to 6. Next you can write that is x follows normal 170, 6 square. So this is mu and this is sigma square. Next is to write the formula for the standard normal variate. So we know that z is equal to x minus mu divided by sigma, which follows normal 0, 1. So it's important to write this formula. Even if you go wrong in the problem, you will get at least 1 mark for this formula. After this, let us start with the first subdivision. I'll write subdivision A. Consider should find the probability, the value of the variable, that means capital X is below 155. So X is less than 155. Now the standard normal tables which you have is in terms of Z. So you have to standardize X. So standardize means from X you should subtract mu and divide by sigma. And from 155 also you should subtract mu and divide by sigma. So you'll get this is equal to probability of x minus mu divided by sigma is less than 155 minus mu divided by sigma, which is equal to probability of, you know that x minus mu by sigma is nothing but z, is less than 155. In the problem, mu is 170 and sigma is 6. So we will simplify this in the next step. So therefore, we got probability of x less than 155 is equal to probability of z is less than minus 2.5. Now we have to draw the standard normal curve. So here I'll draw the standard normal curve. It should not be very peak nor it should be very flat. Now the center line you mark it as z equal to 0. The left extreme is minus infinity and the right extreme is infinity. Next you have to look at the value which you have got here, that is minus 2.5. It is a negative value. So mark minus 2.5 on the left tail of the normal curve. So here I have z equal to minus 2.5. Now whenever you have the less than symbol, you have to shade to the left of the value. This is important to remember. So when you have z less than minus 2.5, it means all the values which are below minus 2.5. So you have to shade to the left of the value. This is an important point to remember. So now let me shade to the left of the value minus 2.5. So shade from minus 2.5 to minus infinity. So you can use any type of shading. So I'm using yellow color in the shading. Now whatever area I have shaded, I will write it in words. So I shaded from minus 2.5 to minus infinity. So that I will write it in words. This is equal to area from minus 2.5 to minus infinity. Okay, so this is important to remember. Okay, that from the statistical tables you can find out the value from only z to infinity, but you cannot find out from a negative value to minus infinity. But because the normal distribution is symmetric, the area from minus 2.5 to minus infinity will be the same as the area from 2.5 to infinity. So let me rewrite this step. Since the normal distribution is symmetric, this is only for your understanding, it's not required in the exam. So I will rewrite this step now. This is equal to area from 2.5 to infinity. Then from the area under the normal curve, the normal distribution, you can get the area, and the area is 0.0062. So the final answer, therefore, probability of x less than 155 is 0.0062. Remember that probability answer should always lie between 0 and 1, and it cannot be negative. Now let's start with subdivision B. Consider probability of 170 is less than x is less than 182. So because the normal distribution areas are given in terms of z, you have to standardize. So from all these terms within the square bracket, you have to subtract mu and divide by sigma. So you'll get probability of 170 minus mu by sigma is less than x minus mu by sigma is less than 182 minus mu divided by sigma, which is equal to, substitute for mu and sigma now, this is equal to 170 minus 170 divided by 6. X minus mu by sigma is nothing but z, is less than 182 minus 170 divided by 6. So 170 and minus 170 will get cancelled. So 0 divided by 6 is 0, is less than z, is less than 182 minus 170 divided by 2. If you simplify, you will get the answer as 2. So now we should find the probability of z lying between the values 0 and 2. So let us draw the standard normal curve. So mark minus infinity, center line is 0 and the right extreme is infinity. Now 0 is already marked, it's a central line. The other value here is 2. 2 is a positive number, so mark it on the right tail of the curve. Now z is lying between two values. So when z is lying between two values, you have to shade only between those two values. So I have to shade between 0 and 2. Now our aim is to find out the shaded area. How do we get the shaded area? Now remember that we can find out the area under the normal curve only from 0 to infinity, or from any other number to infinity, but we cannot find out from 0 to 2. Okay, so the area which is shaded is from 0 to 2, but from the tables we can find out the area from z to infinity, not from one number to another number. So first let me write the area which I have shaded. This is equal to area from 0 to 2. So 0 to 2 I cannot find out from the tables, but from 0 to infinity or 2 to infinity I can find out from the table. Now look at the starting point of the shading, that is z equal to 0. So from the starting point of the shading till infinity, you draw a flower bracket or any kind of bracket which is simple for you. Then at the ending part of the shading, that means z equal to 2, you draw another flower bracket. Okay. So now our aim is to find out the area from 0 to 2, that is the area which I have shaded in yellow color. So how do we get this area? It is nothing but the area from 0 to infinity minus the area from 2 to infinity. So that is the larger flower bracket area minus the smaller flower bracket area. So this is equal to area from 0 to infinity minus the area from 2 to infinity. Now, as all of you are aware, the total area under the normal curve is unity, or it is 1. So it means that from the central line, that is z equal to 0 to infinity, the area is 0.5 minus area from 2 to infinity can be found out from the tables, and this is nothing but 0.0228. So finally we get, therefore, probability of 170 less than x less than 182 is equal to 0.4772. This is an important and sure question in section E. Do practice these kind of problems. 42nd question. Test at 1% level of significance that the average life of bulbs manufactured by firm A is less than firm B. So now observe the question carefully and read the terms which are present in the question. The word average is present, and if you look at the table which is given, you have two firms, firm A and firm B. The sample sizes for the two firms are 72 and 50, and the average life for these two samples is 1450 and 1455, and the standard deviation is also given for these two samples as 12 and 10. So because of the word average and standard deviation, and that we have two firms, the test is test for equality of means, and it is a large sample test. Why is it a large sample test? Because N1 and N2, that is the sample sizes, are greater than 30. Okay, so this is a test for equality of means for large samples. So just keep in mind that whenever it is test for equality of means for large samples, you need to get 6 values from the problem. So the 6 values, if you observe very carefully, are, let me write solution and then list down the terms which are given to us in the problem. So for this particular test, you will need 6 values. So you have N1 is equal to 72 and N2 is equal to 50. Next, average life. So average life of the sample means it is x bar 1 is equal to 1450 and x bar 2 is equal to 1455. Then they've said standard deviation. This is standard deviation of the sample. So the notation is very important. Otherwise, you will lose 1 mark if the notation is wrong. So standard deviation of the first sample means it is denoted by S1, which is equal to 12, small s1. And similarly, S2 is the standard deviation of the second sample and it is equal to 10. Now, apart from these 6 values, they have given the level of significance as 1%. So it means alpha is equal to 1%. Now, the next important step is to write down the null hypothesis. So H0 you can write in words. The two population means are equal. Now, if some of you find it difficult to write in a sentence format, you can also just write mu1 is equal to mu2. You will still get the marks. Now, versus H1. They have said you have to check whether the average life of bulbs manufactured by firm A is less than firm B. So in other words, you have to check whether mu1 is less than mu2. So this is a left-tailed test. Next, let us write down the test statistic for this particular test. So under H0, the test statistic is Z equal to, it is x bar 1 minus x bar 2 divided by root of s1 square divided by n1 plus s2 square divided by n2, which follows normal 0, 1. So this is important. Learn the formulae by writing it several times. Don't make a mistake, otherwise you lose marks in the formula. So now I'll substitute all the values in the test statistic. So therefore I get Z is equal to 1450 minus 1455 divided by root of, it is 12 square divided by 72 plus 10 square divided by 50, which is equal to, it is minus 5 divided by, if you simplify this, it will become 144 divided by 72 plus 100 divided by 50, which is equal to minus 5 divided by root of, it is 2 plus 2, or equal to minus 5 divided by root 4, or minus 5 divided by 2. So therefore I get Z is equal to minus 2.5. Now this particular test is a left-tailed test. So let us write at this side what is the condition which we have to use for a left-tailed test under large samples. So the condition which is used is you have to check whether Z is less than or equal to minus K alpha. So if this condition is satisfied, then you reject H0, otherwise you will accept H0. So always write the condition at the side. This will help you to make the decision. So we have got the value of Z. Next, we have to write down what is the value of minus K alpha at 1% level of significance. Either you can remember the value, or if you can't remember, you can get the value from the statistical table. Okay, so here next I will write at 1% level of significance minus K alpha is equal to minus 2.33. So now all we have to do is we have to compare Z with minus K alpha. So now coming to the last part of the problem, we will write the conclusion. So since Z is equal to minus 2.5 and you have minus K alpha is equal to minus 2.33. So you see that minus 2.5 is actually lesser than minus K alpha, which is equal to minus 2.33. So at 1% level of significance, we reject H0. So when you're rejecting H0, you should write what is there under H1 and conclude that mu1 is less than mu2. 43rd question. Marks of 5 students are given below. The marks are 35, 48, 50, 42, 45. Can you conclude that the variance of the distribution of marks is 30? Use alpha equal to 5%. Now in this particular question, only the word variance is used. So if the word variance is used or only the word standard deviation is used, then it is chi-square test for population variance. Okay, so now you have to keep in mind the format of the null hypothesis and the alternative hypothesis. So from this question, we will write down what is the variance of the distribution of marks. So this particular sentence, it is with respect to the population. So they have given us what is the variance of the population. So distribution of marks. So this is nothing but the population value. So let us list down whatever is given in the problem. So I'll write solution. Under that you can first write given. They have given us the variance of the population. So variance of the population means it is denoted by sigma naught square, which is equal to 30. And I've also mentioned that alpha is 5%, which is the level of significance. The next important step is to write H naught. So because the question is given in terms of variance, you should write H naught as the population variance is, write the value which is given, that is 30. That is sigma square is equal to 30. So either you can write in the form of a sentence or you can just write only sigma square is equal to 30 versus H1. Now words like more, less, above, below, increase, decrease is not there. So it will be a two-tailed test. So sigma square is not equal to 30. Next, you should write down the test statistic formula. So under H naught, the test statistic is, there are actually two formulae for this particular test. Now because they have given us the x values, that is the marks are given, we will use the formula chi-square equal to summation x minus x bar the whole square divided by sigma naught square, which will follow chi-square with n minus 1 degrees of freedom. So again practice writing the formula several times to remember it. And then here we can write where x bar is equal to summation x divided by n. So let me first write down the x values which are given to us in the problem. The x values are 35, then we have 48, then 50, 42 and 45. So add up these x values to get summation x is equal to 220. Next, we need to calculate the arithmetic mean which is given by x bar. So we know that x bar is equal to summation x divided by n, which is equal to 220 divided by 5. So you will get x bar is equal to 44. Next, in the test statistic formula, we need x minus x bar the whole square. So in the table, the second column you can form as x minus x bar the whole square. Now take the first value 35, subtract it from 44. So you'll get minus 9. Minus 9, when you square it, it will become 81. Similarly, 48 minus 44 is 4. 4 square is 16. Do similar calculations for the remaining values and you will get 36, 4 and 1. And then find out summation x minus x bar the whole square, which is equal to 138. Now that we know summation x minus x bar whole square value, let us find out chi-square. So therefore, chi-square is equal to the formula summation x minus x bar the whole square divided by sigma naught square. So it is 138 divided by 30. Or you will get chi-square is equal to 4.6. So for a two-tailed test, for chi-square test for population variance, the condition which you are supposed to use is you have to check whether chi-square is less than or equal to k1 and chi-square is greater than or equal to k2. So if either of these conditions or both the conditions are satisfied, then you reject H naught, otherwise you accept H naught. So this is the condition which has to be used. So let us find out the degrees of freedom for this particular problem. It is n minus 1, which is 5 minus 1 equal to 4. So from the chi-square tables, you can get the value of K1 and K2 for 5% level of significance for 4 degrees of freedom. So the next sentence you can write is at 5% level of significance for 4 degrees of freedom, write down the values of K1 and K2. So K1 is equal to 0.48 and the value of K2 is equal to 11.14. So you have to compare the chi-square value with K1 and K2 and then write the conclusion. So the next sentence is the conclusion. So since chi-square is equal to 4.6 and K1 value is 0.48. So first check whether 4.6 is less than 0.48. So it is not less than, and next you compare chi-square with K2. So the K2 value is 11.14. So is 4.6 greater than 11.14? So it is not greater. So you see that both the conditions are not satisfied. So you will accept H naught. So at 5% level of significance for 4 degrees of freedom, we accept H naught and conclude that. So because you're accepting H naught, you should write what is there under H naught. So you'll conclude that sigma square is equal to 30. 44th question. The cost of a machine is rupees 35,000. Assuming that the machine has no resale value, the operating costs in different years are as follows. The years are from 1, 2, 3, 4, 5, 6. The operating costs for these years are 1,500, 4,500, 7,500, 10,500, 13,500 and 16,500. Determine the optimum period for replacement of the machine. Starting with the solution, let us write what is given in the problem. So given the cost of a machine is rupees 35,000 means the purchase cost, that is capital P, is equal to 35,000. There is no resale value. That means Sn is equal to 0. So actually it implies that P minus Sn is equal to 35,000 minus 0, which is equal to 35,000. Now let us write the formula for the average annual cost. So the average annual cost is, the formula will carry 1 mark. A subscript n is equal to P minus Sn plus summation Ci divided by n. So P is the purchase cost, Sn is the scrap value or the resale value, and Ci is the maintenance cost, and n stands for the different years. So in the table, I will also mark the year as n. The operating cost is nothing but Ci, which is also the maintenance cost. I have written the years in the first column 1, 2, 3, 4, 5, 6, which is n. The maintenance cost is Ci, which is 1,500, 4,500, 7,500, 10,500, 13,500 and 16,500. In the next column, we write down P minus Sn, which we calculated as 35,000. So for all the years, P minus Sn will be 35,000. Next, let us find out summation Ci. So here we have to cumulate. So first write 1500 as it is. Then 1500, when you add to 4500, you get 6000. Then 6000 plus 7500 is 13500. 13500 plus 10500 is 24,000. 24,000 plus 13,500 is 37,500. 37,500 plus 16,500 is 54,000. Next, let us calculate P minus Sn plus summation Ci. So you should add the third column and the fourth column values. So first, 35,000 plus 1,500 is 36,500. Similarly, 35,000 plus 60,000 is 41,000. Then 35,000 plus 13,500 is 46,500. 35,000 plus 24,000 is 59,000. 35,000 plus 37,500 is 72,500. 35,000 plus 54,000 is 89,000. Now I will show you the calculation for the last column, that is AN. So we know that AN formula is P minus Sn plus summation Ci. So every P minus Sn plus summation Ci value, they have to be divided by their corresponding year. So as an example, let me first find out the AN value for the year 1. So it will be 36,500 divided by 1, which is 36,500. Next, you have to divide 41,000 by 2 and you get 20,500. Then 46,500 is divided by 3 and you get 16,166.67. Then 59,000, if you divide it by 4, you will get 14,750, and 72,500 divided by 5 is 14,500, and 89,000 divided by 6 is 14,833.33. Now you have to observe the values in the last column. That is, you have to check where the average annual cost decreases and then finally it increases again. So if you observe very carefully, from 36,500, you see that the average annual cost is decreasing to 14,500, and then immediately after this point it increases to 14,833.33. So let us mark 14,500 and also mark the corresponding year, which is 5. So the conclusion, you should write it as: the machine should be replaced at the end of the 5th year and the average annual cost is rupees 14,500. So the formula will carry 1 mark, the table will carry 3 marks, and the conclusion will carry 1 mark. So don't forget to mark the year in the table and also mark the average annual cost. With this video, I complete solving the entire model question paper for the year 2023. I sincerely wish each one of the students who are going to appear for their board exams on 25th March 2023 the very best. And I also hope that all the videos which I have uploaded will benefit many of you to a large extent. And I sincerely wish that many of you score centum in your statistics examination. Thank you all for watching and do continue to support my channel.